So we're given an f of x function rule and a g of x function rule. This is a composition because it's combining doing multiple function notations within one problem. You would read this f of g of 1, f of g of 1, and you work from the inside out. So the first thing we need to figure out is what is g of 1. So if I take g of 1, that means I'm plugging 1 into the g function. So that's going to be 2 times 1 plus 3. So g of 1 is going to equal 2 plus 3, 5. So now that I know what g of 1 equals, I can take out this g of 1 and replace it with 5. So now it's f of 5. So I took out that g of 1 and replaced it with 5 because g of 1 equaled 5. And now I'm taking a 5 and plugging it into the f function. So that's going to be 5 squared minus 5, which is 25 minus 5, 20. So your answer there would be 20. Okay? Let's jump to C. G of 0. Okay, so we start in the inside and we're going to figure out what g of 0 is. So g of 0 equals, we're going to plug 0 in. 2 times 0 plus 3 is 3. So now that g of 0 equals 3, I can do g of 3. And so now I'm plugging 3 into the g function. 2 times 3 plus 3 gives us 6 plus 3, which is 9. So our answer is 9. So the first example we did kind of did a composition with 2 different functions. You can also clearly in C do a composition in the same function twice. You plug in 0, see what you get, and then plug that number in, see what you get. You also can do, and I don't have one here, but you can do 3 compositions. I could do f of g of f of 3. And you would work, see if I got the right number of parentheses here, you would still work from the inside out. You'd figure out f of 3. That would be 4. If I do it really quickly, plug in 3 in my head. That would be 4. Then you would do g of 4, and that would be 11. And then you would do f of 11. And you kind of just you can stack these up and do as many of these in a row as it asks for. Okay? D, E, and F are the exact same thing. They're just using a different notation. But this means the exact same thing. This is f of g of negative 2, and you still work kind of right to left, inside out. You find g of negative 2 first, which will be plugging in a negative 2 here. So that's going to be negative 4 plus 3, which is negative 1. So if g of negative 2 equals negative 1, I do f of negative 1. And when I plug in negative 1 squared minus 5, what do we get? Negative 4, correct. Because negative 1, when you square it, is positive 1. 1 minus 5, negative 4. And that's your answer. Any questions on this? Key components work from the inside out. Okay? Take one function, or from right to left. Take one function notation at a time. Get an answer, plug that answer into the next one. Get that answer, plug that. It's a domino effect. Okay? So that's compositions from equations. We also can have compositions from graphs. We won't have to calculate as much. We just will have to look at the graphs to get our numbers. But the process is still the same. We're going to work from right to left. So the first thing we're going to do is find f of 2. Well, we have two functions that we're looking at. We have this one, and they've labeled this the f of x function, which is a line. And then they have the parabola, or quadratic, and they're calling that the g of x. So when they say to find f of 2, we're going to look at this graph. So looking at this graph, take a minute to try to find the value of f of 2. Rory, what do you think f of 2 is? When the x coordinate is 2, so we're here on the f of x graph, what's the y coordinate that goes along with that? It's got to be a point on the line. 2, 3. So f of 2 equals 3. That's that point. So if f of 2 equals 3, now I'm doing g of 3. So take that over to the g graph and take a minute to think about what g of 3 is. Fred, what do you think? Rory, do you agree with him? Yes. 1, 2, 3, 1, 2, 3. So g of 3 is 3. Good. And that's your answer for the whole problem. Okay? We can also kind of double up here. f of 0. So the first thing you're going to do is find f of 0. So go to your f graph. What do you think f of 0 is? Take a minute. McKenna, what's f of 0, do you think? 2, very good. f of 0 is 2, so that's 2. So now we're doing f of 2. Take a minute to find what f of 2 is. Jake. 3. f of 2 is 3. And that's your answer for f of 0. Does this make sense? Okay. Flip over to the back. We can also do this like we did yesterday with polynomials. So in this exercise 4, given the function f of x, I'm just circling it so it pops a little more. Given the function g of x, we're going to determine the formula for f of g of x. Okay? So now I don't have a number to plug into g. I just have g of x. And I know that g of x is 5x plus 4, yes? So I'm just going to do f of 5x plus 4, which we did yesterday. Requires plugging 5x plus 4 into the f of x function. So it's 3, and I'm taking out the x and plugging in 5x plus 4. And then the minus 2 is at the end. And I'm going to simplify that. Distribute your 3. 15x plus 12 minus 2 is 15x plus 10. So f of g of x is 15x plus 10. Okay? There's no way just to look at those and just voila, there's your answer. You have to go through that plugging in process. Okay? Yeah. This one here. I took this right here because I was plugging 5x plus 4 into that. It was f of 5x plus 4, so that had to equal 3 times 5x plus 4 minus 2. Is that, do you see that now? Yeah. Good question. Okay? So try g of f of x sort of on your own. I'm taking f of x, and f of x is 3x minus 2. So I'm taking 3x minus 2 and plugging it into the g function. And I'm going to randomly take 3 people's and look at them. Well, that's no fun. They're all the right answer. Take it back. Can't go same one 3 times. Who didn't say the wrong answer? Who's going to be a champ? Oh, share it. Okay. No, Fred, that's right. It's 15x minus 6. Be honest, who had the wrong answer? And then can we share it just to learn from it? Try to figure out what his confusion was. I'm sure other people got it wrong. They're just not manning up like you just did. So I appreciate that. All right, so here's his work. Andrew, what do you see? He was supposed to put it into g of x, right? He replaced the f of x, and we're supposed to plug this into g. So this 3x minus 2 needs to go into the g function right there. So 5 times this plus 4. You did 5 times itself, okay? So you're really you're taking this g function, you're taking out the x, and you should be plugging in the 3x minus 2. So that would be 5. You're plugging in a 3x minus 2, and then plus 4. Yes? So 15x minus 10 plus 4 is 15x minus 6. Okie doke. All right, I want you all to try the multiple choice. Can you pass this over, because one's Madeline's and one is, what's your first name again?
John.
John, that's what I thought. I asked you that already, didn't I? Try the multiple choice one on your own. And be ready to hold up a number for what you're going to choose. 3, hold up your answer. 1, 2, 3. Well, most people are picking 4. Well, that's good, because that's the right answer. So for those of you who didn't get 4, let's make sure we see why. So we're taking g of x, which is x minus 5, so f of x minus 5, and we're plugging x minus 5 into the f function. So that's just going to be x minus 5 squared. And when we squared it, it appears that most of us are doing that right. Have we reviewed how to square binomials yet? Or I can't remember. Yeah, good. So I was expecting maybe some people to accidentally pick 2. So when you FOIL this, x times x, x squared, minus 5x, minus another 5x, plus 25, makes x squared minus 10x plus 25. Nice job. Okay. So 6 and 7. Immediately, I'm sure you're all afraid, okay, but this is asking us to do the same thing that we have been doing. It's just got some context surrounding it, so it's a word problem. But the skill is the same. So scientists are modeling the intensity of the sun. I is the intensity of the sun as a function of the number of hours since 6 a.m. So there's that phrase again. I is a function of the number of hours since 6 a.m. Does that make sense, how the intensity of the sun depends on the hour of the day since 6 a.m.? Right? Okay, here's the equation for that. They then model the temperature of the soil as a function of the intensity using this equation. Does it make sense why the temperature of the soil is kind of dependent upon the intensity? Yes? Right? If the sun is more intense, the temperature will be hotter. Good. And so there's that formula. Which of the following is closest to the temperature of the soil at 2 o'clock p.m.? Okay, I can't get the temperature of the soil without the intensity. And they didn't give me the intensity. What did they give me? What'd you say, Andrew? Right, but when they say at 2 p.m., they're giving me the hour of the day, right? How many hours after 6 a.m. is that? 8. So H equals 8. So we're looking for really what the temperature of the soil is going to be in the 8th hour. Unfortunately, I can't get the temperature based on the H being 8. What I can do, though, is I can use the H to find the intensity, and once I find the intensity, I can plug it in here and find the temperature. Do you see the composition happening there? So really, I want to find T of I, but I don't know I. Because all I have is H. So I'm going to work inside out. I'm going to use that H of 8 to find the intensity at the 8th hour. So I at the 8th hour, and you definitely need your calculators for this. (12 times 8 minus 8 squared). Get that numerator and then divide that by 36. I get... Ooh. It's a really long decimal, right? 0.8 repeating. But then that's my intensity, and then I can now find my temperature by plugging in that intensity. So T of 0.8 repeating, I'm just going to save that number on my calculator, and I'm going to do the square root of 5,000 times 0.8 repeating. So when I type in the square root of 5,000 times, are we aware that we can just scroll up and just hit enter and grab that exact same number and the calculator will bring it down for me? Did you know you could do that? Okay, you can go up and select a number, especially if it's a crazy decimal that you don't want to rewrite, and pull that down, and we get 66.6 repeating as our temperature. The temperature of the soil at 2 p.m. So what's our answer? 1, 2, 3, or 4? 3. Okay, so yes, it was a word problem, but not anything crazy. We're not done. Do you think I look like a person that likes to waste 3 minutes? No. Number 7, Micah, go ahead and read that. Okay, so the speed is a function of the Kelvin temperature, but the Kelvin temperature is a function of the Celsius. So you can kind of, again, hopefully see that domino effect. Speed is a function of Kelvin, which is a function of Celsius. So we want to find the speed when the temperature is 30 degrees Celsius. We're going to find S of K of 30, and we're going to work inside out. Okay, we're going to change that 30 degrees Celsius to Kelvin, and then take that number and plug it into the speed formula. Does that make sense? Can you see that without doing it? Why am I handing out a second homework assignment? It's a Friday spiral. When are these both due? Monday. The answer is at the bottom of the spiral this time, so you will begin to remind message with them. Have a great weekend. Yeah. You didn't get the homework? Oh, so I probably only sent back 3. You just got the